All right, we're going to do some live coding around a facade library for React written in scalajs. The facade library is designed similar to the ReasonReact facade library that's been created by Facebook. ReasonReact is a OCaml derived language in facade that covers up React.js. Reason is the OCaml part, React is the React.js. And the idea is that Reason is like OCaml but made more friendly from a syntax perspective to JavaScript programmers. And it's become very popular to use this language to write browser-based applications now because it has much stronger type checking. As a Scala programmer, I want to kind of have the same new API and design that ReasonReact has, but use it in Scala. I've written a library here that allows you to use that ReasonReact design for the facade. It's called scalajs React, and there's a couple libraries out there already called scalajs React, including one that's probably the most popular facade for React in the Scala world. But this one is actually a ReasonReact approach to it. And if we kind of scroll down, you see there's lots of documentation for it, demos, and actually a template for it. So the idea is that we want to use the template to get started quickly. And what we should do is just go ahead and translate a example from ReasonReact over to scalajs React. Now, the classic example is always a to-do, but for live coding, we probably need something a little bit smaller than a to-do. So we're going to go ahead and sort of take a look for React examples community and see if we can find a good example to translate sort of on a live coding basis over to the new version. So I actually do know that there's a fetch example already available that that we can go ahead and translate. Now, this one looks like it goes off to a dogs API and retrieves a list of dogs, and then eventually renders them to the screen. It looks like it renders them as a list with a header up here. And then there's a small amount of reducer logic, because in ReasonReact, reducers are built into every component if you want to use them. You don't need to have Redux or anything external like diode, etc. There's a reducer component that just tracks the status of the data load, kind of in a classic React remote fetch data example. So we're going to go ahead and take a look at our example here. So we're going to use our template, and the template is now done. We're going to go ahead and go down into it, and we'll type npm install because we know that we need to actually install some of the JavaScript frameworks and capabilities into the project. And based on the README that's in the new project folder, I need to run npm install, and then npm run start would actually start up the application and open a browser window for us so we can kind of see it in action. So we see npm install taking a little bit of time to install a fairly large number of npm packages needed to run the Webpack, which is a bundling program that manages the build process. Obviously, we still use SBT to do the scale up part, but the Webpack program actually bundles up all the JavaScript. And so this template actually handles both TypeScript, JavaScript, and Scala all together if you want to use all those languages in one project. And then Webpack will bundle all those parts together to create the final bundle that's loaded into your browser. And it's a general purpose build tool, so you can use it for whatever you want. So let's just go ahead and type npm run start and just make sure that the template worked as expected. It'll take a moment for it to actually run, as we see here. I'm going to make that a little bigger. To run Scala, and it's doing a fast stop to go ahead and compile it. And then once that's compiled, it will bundle together all the JavaScript that's output from Scala plus anything else that's in the getter template here into a final JavaScript bundle for the browser. Then run a server, and then open up a browser window to that. So that's what that start does for you. Let's just kind of go back to the example real quick, though. So we're going back to our Emacs editor here, and we want to start doing a little bit of coding because this has actually a template for a general purpose application, and we want to actually just use it to create this version of this fetch example here. So let's just go ahead and we see a whole bunch of content here. We see that the example uses Fabric, which is a widget library for React. We don't actually need that, so we're going to go ahead and just delete that. And we'll clean up our imports here. This looks like it is a little bit wordy, so we're just going to kind of bring that in. There we go. And now we got our imports cleaned up. We'll have to add a few more as we go through the coding, but let's just go ahead and delete some of the application content that's here that's no longer relevant. So this is our main. We see that the export at the top level is a single, in this case for this application, a single function called app, and when it's called inside of some HTML, it will actually run the Scala code. We can see that the Webpack dev server is finally started up after compiling the Scala and any other JavaScript and TypeScript code, and it's bringing up a browser window to show that. So we're just going to go ahead over to the terminal again. We see that indeed it did compile, and then Webpack started bundling all this content together. We can see the size, 5 megabytes, which is a development version of the JavaScript file that it then loads into the browser. And we can see that the original getter template for scalajs React actually produced a to-do application, so we could have our to-dos here, and we could go ahead and do that. But we don't actually care about that because we're going to use a new example. Let's go back to the README file, and we can see down here that for development, we just really need to be able to run an SBT, either a build fast or actually just kind of do a quick build using fastop.js. And then as long as we have this Webpack dev server running through npm run app dev start, then we can go ahead and have the server update the browser anytime a JavaScript file changes. We don't have to do anything on the Scala side or the build SBT side. That can all be handled by the tool here. So we're going to go ahead and stop that server, and we're going to go ahead and say run app dev start, and that's actually going to basically rerun the server just like we had done before. It'll open up a new tab or correct this one, but it should show pretty much the same content as before because we haven't initiated build on some of the code that we're about to change. So let's go ahead and start up through our Scala mode, a fastop.js, and what that's going to do is run SBT inside of Emacs and allow us to jump to errors, but it also through SBT, through scalajs, is producing the JavaScript file. And that JavaScript file, when it is changed, so anytime I run this through Control-CC for me, which runs the SBT process, it will actually go ahead and trigger the the Webpack dev server to run. And so if it runs successfully, it produces a new JavaScript file, which then this server picks up, and then it updates the browser. So we get that make a change, compile it when you want to, and see it in the browser type field to it. So let's go back and make some more changes here. So we don't need the sort of the existing app here. And let's just call our new app fetch example. And of course, I got to spell it correctly. So let's just do that. And it'll be a function that we call that provides the scalajs React component into the React DOM render call. And we can see that we pretty much have everything we need. So I'll tell you what, whoops, I think we're going to need that, but we don't need that anymore. And I think we don't need the VDOM either, virtual DOM. And I think that's really about it. So now we have our tiny little example going here. And let's go back to the code that we're trying to look at. So now we need to reproduce this component, this fetch example component. Of course, that's why we named it fetch example. So let's go ahead and go into the directory here, and we're going to just go delete that CSS file. We no longer need it. We'll delete the message file. We're going to keep the to-do for a second. We'll just rename it fetch example. And the reason we're doing that is because it has a bunch of imports in it already. So we save ourselves a little bit of trouble here. And again, we don't need the fabric stuff, which is a toolkit. We do need our virtual DOM and some tags. We don't need fabric. And I'll just go ahead and do the same thing, which is clean up the imports here. Kind of by hand. I don't need React DOM. There we go. That's all that we really need from scalajs React. And I don't think we'll need that. I don't think we'll need that. So, all right, now we're about ready to write the component. So let's just go ahead and type in fetch example. And we'll just delete everything that's here. So now we got our file to go code from. So let's just kind of keep it simple, not overthink the problem. So let's just go ahead and select this content, and kind of line by line, function by function, we'll go ahead and change it into the Scala version. And we'll see that the roughly 75 lines of code roughly changes into about 75 lines of code, less all these imports. All right, so here we go. Fetch example. We're going to get rid of that. We see that we have a type of dog and it's a string. So we're going to go ahead and just reproduce that. We have a state. And we could represent state usually as a case class because it makes it easy to copy. In this case, it's just a ADT. So we're going to use a sealed trait. And looks like we have a loading object. Case object loading extends state. And we have an error object, although it doesn't contain any extra information about the error. So we'll probably need to use some print statements along the way to print out to the console. We'll see how to do that in a second. So let's see, case class loaded. We're going to keep this all kind of very JavaScript friendly by using a JavaScript array. And we'll say it's an array of dog and extends state. There we go. So we've used an ADT inside of Scala and a case class, but the data itself is kept as a JavaScript array. And we could have made that a sequence or a list in Scala land, but there's no need for such a simple component here. All right, so now we got the state. Now we need to kind of do the same thing with the action. So let's just say case object dogs fetch extends action. This is the action that we're going to use in our reducer that says go do something. So let's say case class dogs fetched, and we'll say dogs, and this is the JS array dog like we had before, and it extends not actions but action. And then we have another case object dogs failed to fetch extends action. So we're going to use this in our reducer that again is available if you so choose optionally inside of our scalajs React component. We'll handle the decode here in a second, but now we have the component. So in scalajs we just sort of say, or excuse me, scalajs React will say a val is equal to reducer component, and there's a state and action type. And get rid of the semicolon there. And then, per the documentation for this, we need to say import the ops. And what that does for us is actually import a number of types and implicits that allow us to reduce the amount of typing that we need to do on a lot of functions. So if we go to our documentation and say creating scalajs components, the standard model is to kind of define some information, but define our component, import those ops, and then use a make function. Now make is the classic function name for ReasonReact, but we're going to use an apply here because that allows us not to have to type in .make. And it more looks like a object creation or object call from the code. In fact, if we go over here and we look at the code that we just wrote, then we can see that we want to say fetch example with parentheses, which is def apply. The ReasonReact kind of convention is always to use .make, but we don't need to do that unless we want to. So let's go ahead and say def make, def apply, and the trick here is that we need to copy our fundamental component, which is C, and then we're going to add some methods that are customized for what we're doing here, and we're just going to kind of delete this. One of the things we need to do is set up some initial state, and that's a required function. So we have initial state, and that's going to be self to loading. Whoops, loading. There we go. And that looks pretty good. In fact, we don't need to have self there at all. Self is kind of like a this pointer in JavaScript, but it's specially formulated so that it's always the right type, and it always has only things that you're allowed to use inside of scalajs React at the time you need it. The ReasonReact is kind of very similar. So we got our initial state function call, which is good. Now we have our reducer. Again, we're just kind of going line by line. Our reducer needs to take an action and a state and then generate a update request. For example, update the state, or don't update the state to escape, skip updating it. So it's also required, so it has to be a val. And we know that this comes in as an action for the arg state, and then a generator function which allows us to actually create a updated or update with effects, the equivalent of that in ReasonReact. So let's just kind of go in here, and we're going to say action match, and we're going to delete that, and we'll say this is case dogs fetch, and we're going to handle, it looks like it needs to do an update, so we use the gen function, gen update and effect, and the update is the update to the state, and that state's going to be let's see, what is that state going to be? It's going to be loading. It looks like the initial state we had is loading too, so that doesn't quite make as much sense. So I think that what we needed to do is come down here and say, oh yeah, loading is fine. Update an effect. We need a actual effect function here. So we'll say self. We're going to leave that for a second with all this little nasty JavaScript ReasonReact code kind of sticking there as a big comment. And delete some more content here. And as long as our parentheses match up, we're going to say case dogs fetched. And here we say gen update and loaded dogs. Okay, that looks about the same. And here case dogs failed to fetch and gen update and error, and that kind of looks like it's about the same. And let's see here, do I have enough parentheses? It doesn't look like I do, so let's type in a couple. Yeah, there we go. Just got a missing one. And now that should complete the some of the matching we need to do. Let's see, gen and effect. We need an extra one of those. Now we got our proper indentation for the match. There's not much else to this. I'm going to delete that parentheses. And now we're good on the syntax for the match. Now we have a did mount. This is an optional function. for a component. So we have self send dogs fetch. So upon the mount, it looks like we're just sending a message to the reducer to actually go fetch the dogs. And so what would happen is that it would execute this action, which actually does the fetching for us. So that's kind of a good model here. All right, so let's kind of go in here and take a look at the render function. So the render function is actually quite simple, and there's not a whole lot to it. So it is a required function. So we're going to say val render, and we're going to take a self, and then we can delete that. Self state match. We're matching on the state, and then we're going to, the state is an error, so we need to have a case statement. Same thing here. We want to do a div. We want to return a div. So we're using our virtual DOM inside of scalajs React, and that just comes out to be a simple little function there. Okay, that's good. That's kind of done. It's a little bit smaller. In fact, we'll just put it up on the same line. Ooh, there we go. And same thing here. It looks like it's just a div saying it's loading. So that's not very exciting. And I think we're done with that. And then we got our loading. Looks like we use a div. There's no parameters for it, so we can just kind of jump into the children. And again, you don't have that JSX syntax like in ReasonReact. So we just have this kind of simple function call model. And there we go. Extra parentheses. Then it looks like we have a link. So we're just going to say A. And here we have to say new A props, because there are some props that are needed, like the href. So we're going to just convert it that way. And then we have some children, which apparently the only child is the string or the URL itself, which one could click on if you wanted to. So that looks nice. And then we have a unordered list, so it's going to show up with some dots. And we need to essentially, I got a lot of extra things here. I got a match statement and myself, and then I can delete kind of this stuff here. And I know I need something else to close out my new methods definition. So it looks like I have some content here that I need to translate. So I'm just going to kind of do the same thing, which is comment it out for the moment, and then we'll go in and actually rewrite that. So now we have most of our component written. Yeah, maybe we saved a few lines, maybe not. We're not trying to save that many lines, but it looks like we need to map over the results. So since we are calling our state loaded with dogs, we're going to say that dogs map dog, and it looks like we're going to do a li component, and we need a new key on here. There's a couple ways to do that. I'm going to do it kind of the very long verbose way, which is just add the props and add the key there, and then the actual dog itself gets added. And there we go. We finished out the closure there for that mapping function. It looks like we got hopefully still pretty good content here. All right. Let's see if we can just get a compile real quick, where we might have some errors. Looks like we got a couple errors, so Control CE says I need to fix that to a dog. Send actions, that should be an action. Dogs failed to fetch gen update error. Now the question might be, why is that a problem? And you'll also note that we don't actually include any error information around that. So maybe we should print out some console messages, but let's just take a look and see if we can figure out what the error is. And we need an action type here. Dogs failed to fetch I think I fixed that. So Control CC to run faststop again. And the answer is yeah, we want to save it. Now, again, we have our terminal here that is saying, hey, you haven't done a successful Java or a Scala compile yet. I still have some of the old content loaded in my little memory buffer. Can't find a file now because he deleted it. As soon as we get the compilation to start working, this will actually pick up the new Scala file, now converted into JavaScript through the scalajs compiler, and again automatically update the website. So we're just going to go over to where the app had popped up, and it's still on the to-do app because it hasn't received the new app because it hasn't compiled yet. So let's just go ahead and take a look and see if we can figure out what's going on. Okay, so here missing parameter type, so it's expecting us to type this, but we already have a lot of typing information in here. It turns out that these optional functions inside of a component, these lifecycle methods, when they're optional, they're defined as JS_UNDEF, so we know that because implicit resolution does not double dip, we need to give the compiler a little bit of inference help. So we type in JS_defined, and now it should recognize the function and pick up the typing there. So it's a little bit better. Let's see, and I need to not say undefined, but defined. I should get a compilation here. Let's take a look here. And I'll probably just show you either an error or loading because we haven't actually written the code that actually does any loading, assuming that it compiles correctly. So while it's compiling that, let's just go up to the decode here. We need to decode the response from the API call. We don't know what that response looks like exactly, so we're just going to go ahead and grab the URL and then go over here, and we can see that the Webpack dev server did pick up the freshly changed Scala file. Now it says loading. Of course, it'll not ever load until we write the loading code. And it looks like we have a code in here. So let's see what kind of message we get. We get a status, and then we get a message that actually has an array of, looks like dog names, all lowercase. So let's just write a response trait. So we're going to say API response, and that's going to extend JS object because it's coming back as a JavaScript thing. And we'll say it's JS native. Saves ourselves a couple bytes of code there. And let's see, we have a status. So maybe it won't have status one day, but it is a JSON data structure. So we're going to do undef4, and it's going to be a string for the status. And we'll just assume that it's undefined unless we know better. And we gotta type that correctly. And then we have a messages. Let's see if that was right. Message. Or string. Oh, that's not a string. That's an array of dog. Not dag, dog. JS undefined. And now we got basically our decode, which we're going to decode to the API response. We'll call it singular here. And then down here, we need to actually perform the fetch. So we know that there's a package, the DOM package, and that has a few things that we could use for this. So we'll say DOM. I think it's in the experimental package is where we have the actual fetch function, and then the fetch is going to return a JavaScript promise which will convert to a Scala feature. So we're going to need to have a implicit execution and scope. So we'll just take the global one because it's JavaScript. There really isn't more than one if unless we really want to have some fun here. So let's just now call the fetch, and let's see here. Need the API, so let's just delete all this stuff. Now we got it. Now, because we can import the experimental there, we know that if we pull in some more implicits as well, we can actually pick up some ability to automatically convert the JS promise to a Scala feature. So we'll say venable implicits underscore. And that implicitly allows us to convert something rather easily. That makes us happy. So now we got our fetch. And now because the fetch has a JS promise, in fact, let's just go check that real quick. Let's look up the Scala API. Scala API, let's say Scala JS, GitHub, JS converters. Don't think that's where it actually is. That's not the right. It's not the right place. This allows us to convert from some Scala to JavaScript, or from JavaScript to Scala, but it doesn't have the implicit for what we want. If we go to the bottom, we can take a looks like a future to a JavaScript promise, but that's going the wrong way. So let's just say let's look for toFuture in this repo. Oops, I hit all of GitHub. I don't want to do that. So toFuture in this repo, and oh, there we go, in the Dunable. And let's see what the API call looks like. Dunable. Yeah, there's toFuture, and there's the implicit that I remembered. Okay, so yeah, I remembered that correctly. All right, so that's good. If it's a future, then we just have to run a onComplete. And we have a couple ways we could compose this to be super clever about how this works. But with an onComplete, let's just say that we're going to match on the completion, which for a fetch is a response object. It's a fetch response object. So it's got to be case success. We want JSON. We know that fetch has a function in there that allows us to basically convert it to JSON for us, and it'll fail the promise or the future if it doesn't convert correctly. And I got a map. Let's see, we need to figure out what that API looks like, so let's just go ahead and say Scala JS DOM, and let's go to that project. And in this repo, we're going to say look for fetch, this repository, and there we go, I click correctly, and experimental package, and here's the fetch function, and it looks like fetch returns a promise of a response. That's good. And then if I have a response object, it looks like, where's my response object? That's the request. There's an apply requesting init. A response, here we go. Response object extends body. We can check whether see if something is okay, but we know that our futures and promises kind of handle that for us automatically. So let's just kind of take a look here. Here's body. Body used, array buffer blob, form data, JSON. Here's what we like. We get a promise of a JSNE if we convert it to JSON. So it's pretty clear if we have a JSNE, we're going to need to convert that. So we do have to have a cast. We can't avoid that. And that's going to be an API response. And now, yeah, I have API response coming in. And so I can delete that. I can delete that. Decode dogs. I'm going to delete all that. So now, if I've successfully parsed the response and it does exist, the response object has a status and message. We saw that up here. And it's a JS undef, which is like an option. So what we can do here then is just, first of all, let's log it. In case we want to look at it for some reason. All right, that makes us happy. And then let's say API response. We're going to fold over that to get the information out. The first function to be provided is when it fails. So we're going to say DOM console log error. Error for some reason, right? I'm not sure why it would fail here. but it can. So we'll say API response. I think, fortunately, we're almost done here. And then we're going to send a message, which is self-send. So I get this right. Self-send dogs failed to fetch because we're still in the failure part of the fold. And then we have the successful part, which means we get some dogs. We're just going to say self-send dogs fetched dogs. I'm just going to actually just get rid of that too. Keep it easy. There we go. And it's only one function, which means we can also just do our little, there we go. All right, probably not the neatest thing in the world, but yeah, it should work here. So put it on a new line just for fun. All right, let's see here. We finish up the match, and we finish up the onComplete. 2 brackets in a row. We probably don't need that, but we'll keep it. And that should be it for the fetch. So let's see if we can compile here. And looks like we have a little bit of a problem. I'm just going to get rid of that since I don't know what the problem is. I want to take the time to figure it out. And API fold, can't fold on that, I need to fold on the message. There we go. And there we go. Let's see if that works for us. Illegal start a simple pattern. Oh, there we go. You need to add that. And of course we've forgotten the entire case of failure. And the failure is going to provide some type of exception. And maybe since we don't have a way to convey the failure using this example back up to the UI because of the very limited way that the failure has been defined, we'll just print it out to the console and then say self send dogs fetched, dogs failed to fetch. And let's see, missing closing brace. I think we're just about there. Oh, fetched. Oh, and then we need a one of those. Hey, you said that these C-like languages weren't as bad as Lisp for parentheses. All right. Success and failure not found, so I need to go import those. And I think that's in the util success failure package. Oops. There we go. Now we still need to write the fetch code. So let's see here. Dogs fetched. Throwable. Found any. Okay. Oh, it's going to be a JavaScript. Or excuse me, a Scala structure, that throwable in the failure. If that was a JavaScript structure, I'd probably want to use the DOM console print, but it's a Scala object, it's a throwable. It gets wrapped, it wraps the JavaScript throw object, but now we use print line, and we'll just say failed T, and that should take care of that error. Which it did. That's good. And let's see here. Dogs fetch. Oh, we do have the fetch code. It's right here. Oh, okay. Well, looks like we do have the fetch code written. All right. Let's see where we have an error here. Dogs fetched. Doesn't actually like that, so I'm just going to put in dogs. Maybe it couldn't infer through that. And let's see. Oh, we got a compilation going. Okay, took 8 seconds. That's probably too long, but good enough for what we need here. And let's just go back to our page, which will reload. Looks like it's reloading as I move my mouse over to here. An error occurred. Okay, I'm sure it did. And we don't see what the error is. All right, that's never good. But we did see that an error occurred was printed, and therefore we had the error object there. So let's go see if we can figure out what happened with that. So let's go back and convert this back into a place where we can add a couple statements. All right, so we're going to say print error occurred here, which is not the best debugging approach ever, but at least we kind of get a sense of what's going on. We also see that our real problem is that if we are converting a JSON, converting the response object to JSON, if I go over to the actual fetch definition again, I'm getting a promise, which I can convert to a future. I'm using a map, so I'm mapping into a promise. So I have a promise, and I map another promise. I have a promise within promise, or a future within future. That clearly should be flat map. And I'm going to take that from there, and I'm going to then say that my API response as instance of API response, and then get the message from there. There we go. Hopefully that will make it a little bit more responsive here for that error. Let's go back to our little area. We can see that we get a compiling message in the actual console, which is good. That's coming from Webpack, and it looks like it did work. So if I hit refresh, I basically get the list again. You can't really see it, refresh or flash, because the JavaScript's trying to be smart about what it's drawing there. It's going to look exactly the same, and the response from the API is very fast. All right, so it looks like we were successful in recoding this. And let's just go take a look at the code again. So we converted state and action almost directly. We defined a JavaScript trait called API response to outline the shape of the response from the dogs API. We have our initial state, which is just loading. We have a reducer, which is built into every component if you want to use it. And for each action, we have to generate do a match, and then use the gen function to generate the return value. In the case where we're fetching, we have an update, and then we have an effect. And then for the other ones, it's really just simply updating the state, either loaded or an error. And when we mount, we actually start the fetch, which is pretty standard React.js, and then down in the render, based upon the state, we choose what to render, which is also very standard React.js. But you can see that we've formulated it quite a bit different. Our line count came in at about 89 lines, but we also have about 15 lines of imports, which the React or the ReasonReact does not have. So we can see that on a line count basis, we're at the same line count. Code's probably just as clean. There's not a lot of type information we needed to provide. We had to do a whole bunch of crazy import statements, which was a bit of a pain. But this allowed us to get this component converted pretty quickly. So that's really it, and I think that's the end of the live coding.